As voter said, I am Ryan. I'm actually Roger Dingledine doing a deep fake of Ryan, but for our purposes, we can pretend I'm Ryan. So thanks for sticking around to the end. I'm going to talk to you about something that I like to call probably private protocols. You may see the title and think I must surely mean provably private protocols, but indeed I mean probably private protocols. So I'll explain to you through this talk what exactly that means. And in particular, I'm going to talk about something that I've dubbed the HotPETS probably private protocols paradigm, or HP6, where taking a clue from DP5, the extra P is for more privacy. Okay, so when I got the acceptance for this talk, I was a little bit unprepared. The abstract started off as just a failed attempt to troll voter, and next thing you know, they told me that my talk was accepted, and so I was left coming up with something to actually talk about here. And as a accomplished educator, I went back to my education roots and said, okay, I want them to learn something from this talk. I need to come up with some sort of learning objective so that at the end I have a takeaway. And I spent several nights just thinking about how to distill what I wanted to get out of this talk into something concise that I could share with you guys. And I came up with this. So by the end of the talk, the audience members should be able to stop rejecting my papers. Oh, we have our first question. Okay. Who's asking this question? Oh, man. Reviewer B. I hate Reviewer B. Okay, what's your question, Reviewer B? Just what in the bleepity blank is this probable privacy paradigm you're peddling? Well, I'm getting there. Okay. Let me answer that question with a hypothetical scenario. Okay, so let's suppose that Ryan writes a paper and submits it to PETS, and reviewer B says, I'm rejecting this paper. So why are you doing that, reviewer B? Because the threat model is wiggity whack. What are you, from the 90s? Okay, I don't know what's happening here. My slide deck has gone haywire. Okay, let's just keep trying to move on. Okay, so what happens here? We have reviewer B. Reviewer B wants to reject my paper because the threat model is, and I quote, wiggity whack. So he logs on to submit.petsymposium.org, the URL for the hot crap for pets. The first thing that happens actually is he types his address into his browser, and his browser submits a DNS query on his behalf that says, hey DNS, please tell me how to get to submit.petsymposium.org. And then this DNS request is dutifully relayed to a DNS server that looks like it might be in Montreal. Is reviewer B Jeremy or Sebastian? Oh wait, maybe that's not what this slide is trying to say. So maybe it could actually be over here if my geography is not too bad. That looks like the UK somewhere. It's possibly actually very likely over here in the Bay Area. I actually Googled it before the talk, and it turns out there's a DNS server down here somewhere near Florida, and a few others scattered throughout the internet. Right, so the point is that what's going to happen here is reviewer B is going to send this request for petsymposium.org to whatever DNS server happens to be configured in their local browser, and that DNS server is going to learn reviewer B going to submit.petsymposium.org right now, and you could see a bit of a privacy problem potentially. So there's been a lot of talk recently about how do you get more private DNS, and one of the solutions, sorry, I didn't mean to hit next yet. Let me go back. Go back. Okay, I went back too far. One of the solutions that's been floated, okay, never mind. One of the solutions that's been floated is to use DNS over HTTPS or DNS over TLS or DNS privacy. All of these protocols attempt to protect the contents of the DNS query while it's in transit. So if you have a network adversary who's spying on your DNS requests, they won't be able to actually read them, and so they won't be able to figure out what domain names you're resolving. But the DNS servers themselves still receive these DNS requests. And in fact, if you look at, say, Mozilla's proposal for DNS over HTTPS, they're actually talking about basically redirecting all DNS to, I think, Cloudflare. Don't mean to cast any shade on Cloudflare. I think the previous talk was from someone at Cloudflare, but submit everything to Cloudflare or Facebook, as if this somehow improves the privacy situation. And so when I looked at this picture of, okay, there's DNS servers scattered throughout the world, it kind of reminded me of something that you may have heard of, which is Tor, as illustrated here. The user just chooses arbitrarily a handful, or it's not quite arbitrary, but effectively arbitrarily chooses a handful of nodes scattered throughout the world, and then forms a circuit through these nodes and uses this to browse the internet anonymously. So this gives very good anonymity for day-to-day web browsing, but it can go wrong, and we all sort of know how it can go wrong. Actually, second learning objective of this talk is you now know how to visualize the global passive adversary. In the case of Tor, if you have a global passive adversary like this fellow up here, he can see everything that's going on, and by using this ability to see everything that's going on, he can use end-to-end traffic analysis and try to figure out which incoming packets correspond to which outgoing packets and violate reviewer B's privacy. But we all accept this. We understand the risks. We understand that we don't really have a better choice, and this is certainly much better than just sending our packets in the clear, so we're all good with it. Okay, now back to our original problem here. We had reviewer B. He wants to reject my paper. He goes to a DNS server. Let's suppose he's using DNS over HTTPS. So he goes to Cloudflare and he sends his query, and then we all close our eyes and plug our ears and pretend that the NSA has never been implicated in like mass surveillance of the tech companies in the Bay Area or anything of the sort, and we say, hey, we got privacy. But another option would be to try to come up with some sort of protocol where reviewer B could, for example, choose a few other DNS servers completely arbitrarily and then do something fancy involving them that if it turns out these 3 servers in this example that were chosen aren't colluding with one another, then now we not only get the privacy afforded to us by DNS over HTTPS, but we could actually prevent the server themselves from learning what we were looking up. So this is a sort of hypothetical scenario where an HP6 protocol might be useful. Okay, what's going on? Okay, so looks like reviewer B is partially satisfied here. He says, gee willikers, this guy is not just from the before times, but from the before times, apparently. Gee willikers, an HP6 protocol for DNS would be way more useful than my initial review admits. Let me update it. I'll write on. I'm getting my paper in. The paper would benefit from a more fulsome discussion of the use cases where HP6 is appropriate. Decision, strong reject. I hate reviewer B. Jesus. Okay. Oh, let's try to address this concern. Okay, so we need a more fulsome discussion of use cases where an HP6 protocol might be appropriate. So, of course, the easiest way to satisfy reviewer B would be to take advantage of the rescue coin that I received for my rump session talk yesterday and just change this review into a positive review. So the paper is truly revolutionary, decision strong, accept, and call it a day. But if most of you don't actually have a rescue coin that you can use to get through the PETS review process, we need to actually address this problem. So I've got a couple of rules of thumb for where this sort of non-collusion assumption that I'm talking about might be very useful. So we'll call these the HP6 rules of thumb. Number 1 is you might have an HP6 candidate if there are many parties to choose from. So kind of like in Tor, there are lots of Tor relays, and the user is free to choose a handful from this large set. So I'm not talking about situations where there are 3 servers and we assume these 3 servers don't collude, but rather situations where there are hundreds of servers and we are going to choose a handful of them and hope they don't collude. Okay. So here, yes, of course, Donald is reminding me that it's very important that not only is there many servers to choose from, but there is no collusion among those servers. So that it comes to point number 2. So you might have an HP6 candidate if those parties that you can choose from are run by independent entities that lack any obvious reason to be colluding. So for example, if you live in a small town like the one I grew up in, and there's a cooperative ISP that is run locally and has no major ties to major corporations, you might say probably their DNS server is not colluding with Google's DNS servers. Maybe it is, maybe it's not, but I don't see why it would be. It seems unlikely. Some jurisdictional or geographic diversity certainly doesn't hurt in this regard. So if you're worried about Five Eyes spying, you might make sure one of these candidates is not a Five Eyes server. I don't even, that's not even really relevant, I guess. There's no incentives to collude, so it's a witch hunt. I don't, yeah. Let's just move on, Donald. Okay, so point 3, you may have a HP6 candidate. If collusion does occur, the results aren't catastrophic. So this is a very important point. We're relying on non-collusion. Non-collusion is a strong assumption. We want to make sure that when it fails, the world doesn't come to an end, right? So this, one of the consequences of this is that you can't use a protocol like this for something like elections. And as Donald is going to point out, this is because, for example, we really have to worry about Russia colluding with the Democrats because they definitely don't want Trump in power. And so you wouldn't want to rely on non-collusion for something like that. Right, so I came up with this handy mnemonic for understanding what is acceptable versus not acceptable when you're talking about the consequences of collusion. So is there collusion? If so, then it should be a return to the status quo. If not, then there should be privacy to be got. So if you think about this in terms of the DNS, if the DNS servers in my hypothetical scenario do collude, then the implications are you have the same level of privacy as people who are not using this protocol. You're not suddenly losing all of the sensitive data that previously wouldn't have been revealed, but rather you're going back to the way things were in the before times, right? But if they don't collude, if your attempt to choose some non-colluding servers was successful, then you get perfect privacy, right? And in order to make that a palatable trade-off, there's one other piece that is needed, and that is that building a solution based on non-collusion yields a blazing fast construction. And of course, you can't just build some other construction, say using public key crypto, that is in the same realm of feasibility. If you can, you might as well use that because non-collusion is a strong assumption that may fail. So I can, oh yes, another interjection from our protagonist here. The only reason to vote for Democrats, you're tired of winning. I don't, the stuff he says doesn't even seem to have any real connection to what I'm saying, but okay. All right, so I've got a nice diagram to show sort of the line between costly versus cheap and where it makes sense to use HP6. So over here we have the no privacy protocol, which tends to be very, very cheap, easy to implement, very fast. And then we have the uber privacy protocol. Say, for example, in the DNS case, we're using garbled circuits. And in order to make a DNS query, you construct the garbled circuit and send it to the server to evaluate or something along those lines. And then we have the probably private protocol that relies on this non-collusion assumption. If the line that says what a normal user would be willing to tolerate happens to be here, then this is a great candidate for HP6, assuming all of the other criteria are met. If, on the other hand, the line is here, then this is silly, and likewise, if the line is here, it's kind of silly. So, but if you happen to be in that sweet spot where we started right here, then you have a nice candidate. Okay. Right, so to summarize, the 4 rules of thumb were there's many servers to choose from. They don't really have any obvious incentives to be colluding, so hopefully if you choose them at random, the ones you chose aren't colluding with one another. When collusion does occur, the world doesn't come to an end, and the fact that you're relying on this non-collusion assumption lets you build something that is blazing fast compared to all other private alternatives that exist. And so a couple of case studies that I'll just mention very, very, very briefly. Last year at PETS, we had a many server PIR protocol where it's a one private protocol, which means if any 2 servers from these many servers collude, privacy is lost. But in exchange for this super strong non-collusion assumption, we got some remarkable performance. And so if we zoom in on this graph, we can see that the old school way of doing PIR, this is sort of per C++, the standard in the literature, could do about 13, yeah, so I can't remember what the record size was, but we were able to process about 13 million rows per second on our our machine when we were running the protocol. But when we ran the fastest HP6 variants, that number went up to 2 trillion rows per second. So the performance difference was, I don't know how many orders of magnitude off the top of my head, a lot of them, which means that in this case, this may be too expensive to be realistic, but by making a super strong non-collusion assumption, we get something that is quite practical. And now the challenge is finding use cases where all of those other criteria I just mentioned are satisfied, in which case we could use this to get free privacy for most people. So the second one is a top secret manuscript that I managed to get my hands on. I can't tell you anything more about it, except that actually it was talked about in the rump session yesterday, so the secret has been outed, but let's just pretend. In this top secret manuscript, the brilliant authors managed to come up with some nice MPC protocols, and I did some back of the envelope calculations, which were also outlined in the rump session talk last time. Or yesterday. So the protocol is meant for streaming video and building recommendation systems on top of streaming video. So we use Netflix as our sort of canonical example of a streaming service. And Netflix has about 14,000 titles. That should be 150 million, but the one seems to have disappeared. So 150 million users. And the average user watches 2 hours a day, and so I just made the assumption that the average thing is at least half an hour, so that's at most 4 titles per day. And so if you take these calculations and you put them into a magical computation box, this is actually just the back of an envelope, and you do some arithmetic and you work this out with the cost of renting the CPU time needed to actually run our protocols on Amazon, this works out to less than 1 cent per Amazon subscriber per year to make everything private. Of course, non-collusion assumption in the case of Netflix doesn't make a lot of sense, but it shows that this sort of protocol could be super practical if we could find the right use cases for it. Okay, so that was most of what I wanted to say. For your homework, if you want full credit, there's 4 things you need to do. So step 1 is identify at least one ideal HB6 use case. Think about all the different problems you've considered in the past and see if any of them might be suitable in this particular model. Step 2 is co-author a PETS paper with me about said topic. Step 3 is, I don't know, and then 4 is profit. Okay, actually, we all know what step 3 is. Step 3 is get tenure, and then profit. I guess it comes with a bit of a raise. And now I'm going to do what nobody better dare do next year at HotPETS. I'm going to steal Michael and Wouter's thunder by proclaiming this to be the end of HotPETS. All right, let's get this discussion going.